All right, we've got a lot of content to go through in this video, and I'm currently almost done recovering from a cold, so I will probably be sniffling and coughing and other stuff. And if that bothers you, I apologize deeply. Maybe just watch the video with audio turned off or go read the associated blog post, as my thoughts are a lot more organized in written form than they are in the spoken form. But hey, YouTube videos are fun and silly to make, and on that topic, why the hell am I making this video? Do I even have a slide for that? I don't think I do. Let me go back to the title. I'm again making an applied review series. In this case, it's because I am studying for the Hack the Box Certified Web Exploitation Expert exam. So each one of these videos will be focused around a module that you have to take for that course. I think there's something like 24 or 28. I don't actually remember the number off the top of my head, but again, this is just going to be like when I did this for Burp Suite. I'm going to go through a module, I'm going to find some CTF challenges that are relevant to it, and then we're going to go through them and talk about them, just so we can get a little bit of practice, and so that this holds me accountable of being diligent with my studies. So without any more dilly-dally, this is probably going to be a long video, so I'm going to try and go pretty quickly, but I might fail. So first, injection attacks. These have been in the OWASP top 10 consistently in some form or another since about 2003, right? So some of these are a lot more commonly known, right? You'll see this on YouTube all the time, like SQL injection, command injection, cross-site scripting, which is basically HTML injection. And you'll find tons of these things littered around, and you'll find that most developers, weirdly enough, are actually aware of these, and lots of common frameworks already have countermeasures built in to stop you from doing this. This might have been your wake-up call if you are a fresh pen tester, maybe out of college or out of your boot camp or however you learned your skills, or maybe out of your CTF experience like kind of I was, and you'll start looking at real environments and say, these guys aren't really vulnerable to this low-hanging fruit stuff. Depending on, obviously, right, the baseline or the minimum security standard for your clients that you're working with. It really depends, right? Anyway, we're going to be going over XPath language injection, LDAP injection, and HTML injection that specifically affects when PDFs are generated. Let's just try and get through this as quick as possible. So this is XPath injection. XPath, or the XML path language. This is a query language for XML. So you can see this is an XML document here. And if we want to write some kind of syntax to query through this XML, you would use something like this. So down here are some example queries. These are kind of what these different parts are. You could select, well, I'll kind of take a step back and explain that there's different element nodes. There's a root node. I don't really understand the purpose of hyper focusing on the syntax or the specific language of how all these different querying languages work, because I feel like most of you are here, if you're here, is just to watch and learn a little bit about what this is actually going to do and how you can use this to get some cool vulnerabilities under your belt found. So, excuse me, that being said, we're kind of going to focus a little bit more on the specific syntax. So let's say we're making a query. We want to get all the book child nodes of the bookstore node. That's how you would do it here. If you want to get all the book nodes, you do it this way. Selecting all the author nodes that are descendants of the bookstore node. Again, so that's kind of highlighting this smaller piece of the syntax. If you just want to get this attribute node, like age, this age attribute node out of the rating element node. Again, right, if you have a root node, this is a tree structure. So you can have multiple, or, theoretically just n number of child nodes, but each child node needs to have a parent node. And then there's descendants and ascendants, I think is how you might refer to it. And then what's more important here are these things on the right-hand side, which we're going to actually kind of have to be familiar with to do some of these brute forcing stuff. And these are called predicates. This is not an exhaustive list. There's definitely more than this. And if you're going through the modules with me, you'll find in the skills assessment that this can kind of bite you in the rear end. So right here, you'll see, okay, we're going to select specifically the first book child node of the bookstore node. In this case, we're getting the first 3 book child nodes because we're using this position predicate to say that. And then in this case, we're using this this at character. Well, I guess we've already talked about this is for attribute nodes, but we're still using a condition here in these with this bracket or angled bracket, I guess you could call it, in saying, hey, only get this where the rating is 15. So this is kind of how these queries are going to be executed. Now, XPath can, of course, be used for authentication in a similar way that, SQL can be used to search for stuff, including usernames and passwords. So let's say that we've got some web app that's querying an XML document and it's passing our input to this XPath query. It's querying the user's root element, maybe. It gets the user node and then specifically looks for the username attribute where the text is equal to Gabe123, and the password attribute or element or whatever has text that's equal to this, right? So let's say our inputs are just username and password, and they actually get parsed into this query like this. Well, just like SQL injection, which we've talked about before, you can just try and make these resolve to true, and then all of a sudden, right, it'll log you in, and you don't have any huge issues. In this first example here, this one, each predicate for like the username and password will evaluate to true, and then we would get logged in as the first user in the list, because the query will return all the user element nodes. So if you want to log in as a specific user, you want to modify this username here. So if we know the username or something, this would work. And of course, this evaluates to true after this, and then so this password would become irrelevant. Keep in mind, of course, in real life, passwords, well, you would hope, right, are stored in databases for later reference and are almost always going to be hashed and salted. So if we're using this strategy of, oh, well, like I'll just evaluate to true and then use, some random password and see who's got this, right? Like kind of a password spraying thing going on. Using this like previous trick won't really work because we'd just be inputting the hash of some payload, so it's not going to result. Assuming nobody's using this like our entire payload this here as their password, the query is not going to return any nodes. So if we don't know a username either, then we're kind of stuck and we need to come up with a new strategy. And in this case, you can do this double or clause, which in essence, I mean, all this really should do is it'll only work for the first user in the list, but what you're saying is where the username is something or yes, or and password is something. So because you're saying username is first person in the list or true or nothing and password is something, it just evaluates, but only for the first user in the list. You can remedy this by specifying the position. So this would be the user who's at position 3. And then again, because of these double ors here, we would, it makes the query return true, and then all of our nodes are returned to us. And then this example down here, if you know someone's username, you can use this contains predicate to search for a username where the text contains admin, and then resolves to true. So you get the idea. This, returns all the user nodes that contain the string admin and any descendants. Since the username node is the child of the user node, this returns all the users that contain the substring admin. In short, there's also some data exfiltration stuff. So just like in SQL, which we've done before, we can use this to exfiltrate something under certain circumstances. Again, there's both blind and normal, I guess, exfiltration. So in this case, we have a, like a search filter for street names, right? So this is your query, and then you can filter by full street name or short. So I guess there's filter for long or short street names. And our input is ALP, and it shows us everything that matches this. So you can imagine a query that's like, show us root node, child node, contains within some node this text, ALP, and then / full street name. So give us this specific element or attribute inside of this. That might look something like this, right? We know that there's it's fetching in here and here and here something, right? And then it's querying for where street name looks like Alpine or contains this text, or where maybe this something here contains this text. And then it's spitting out the full street name. In this example right here, we're not supplying a real one, so this shouldn't resolve anything. And then we're saying or true. So then this should spit out every single possible street name. And because we're not filtering by anything, it's just going to do the long street names by default, it looks like. But because we're not filtering by anything, and this resolves as true for every single element, we get a giant list of results. We've seen this. This is pretty familiar if you've done any SQL injection before. For more exfiltration stuff, if we can't, hold on, I might be getting ahead of myself. So if you want to exfiltrate some of this data, you can use the pipe operator here, which acts a lot like SQL's union operator. And then we could also add this / text. So this will return all the text nodes in the document. That should contain all the text data in the document itself. So in theory, this should spit out the XML doc in its entirety. I wasn't able to get this to work in some instances. This down here is the same, but you also have this, or true evaluation to get the same thing. And then you're just using the filter to get all the text. But I wasn't able to get this to work in the lab. I'm not sure if there was something I was doing wrong, but anyway, there's some more advanced exfiltration here. So this isn't quite blind yet, but if we can't get the whole XML document at once, we'll need to modify our payload to work within these constraints. So in this case here, we're still using this, union-like operator to specify the depth. So we're saying, okay, show me nothing where the full street name is, within this first, what would I call it? Within this first category, or contains, let me think, or wait a minute. Yeah, within this first. So this shouldn't actually return anything because we need to figure out the depth. We've done this with SQL injection before, where we have to figure out your depth in the table. So of course, full street name, if we go back a couple slides, we know it's not 1, 2, 3. It should be about within this fourth element. So maybe like 4 or 5. Whoops, that's the wrong way. Am I in the wrong spot? Oh no, here we are. Okay. So in this case, right, we're trying to figure out our own depth. So we're saying, okay, we're not in the first, we're not in the second, we're not in the third, but we must be in the fourth because now we're actually getting a result here. You'll notice that if you change some of these numbers around, you'll get different results, which makes perfect sense, right? If I were to change this last 1 to a 2, assuming that it's this street name, it would probably give me the short street name instead of the full street name, this last number 1. So again, it's like 1, 1, 1, 1. It might make more sense if we do it from here. So 1 is our, we have our root, we have the street, maybe we have, or let's say this is the streets, no, this is the data set. This is, right, not street, this is users, number 2. And then we say specifically the third group name in users, which is admin. We say the first user, which is this one. And then we say the first thing, which is username right there. So that's kind of how this depth of this query is working. I hope this illustrated that closely enough, because if you're going through this and you don't get this part, it's going to be kind of a pain when you're trying to look around. And then blind exploitation, right? It's the same thing, except you don't actually see the results of your query. So let's say I can send some message to someone, right? Or like we can perform this request, we get an error message, but then when we use this payload, which resolves to true, we get a success message. Okay, that's great. So we are in fact manipulating the query, but we can't actually observe the results like we could. So this should remind you of SQL injection and the painful process of brute forcing or parsing every single character in a table name, then a list of target users, corresponding passwords, dumping them, etc., etc., etc. There is an SQL map-like tool called XCat that the module does recommend you use. I don't really see what that does that a script that you could make with like an LLM couldn't do, so that's what I kind of lean towards using. So if you're trying to get the names of the nodes, here's just some interesting stuff you could use. So let's say you're looking for a name of a node. This is the second character in the so like let's say there's a name element, and inside that name element we're looking at the first one, and we know that the second character in the name of this first one is C. So this is like the full name that I have in this message parameter. That doesn't mean anything for this query for accounts. Let's say we've figured out that there's an accounts node, and we're trying to figure out the next characters. So we'd say, okay, what's the first child in this node? What's the first character in the first child node? And it's A. And then we go through and cycle this second character until we figure it out. Getting the names of the following child, right? Okay, what are the names of the account? What are the elements inside of this ACC, this ACK child node? And so I say, okay, the first one is about 8 characters long, last character E, so I know it's a username, because right, I've gone through the process and brute forced every single character, making sure those responses indicate that it's correct. Same thing for this. Okay, we look at the second child of this ACK thing, and then we go through all the characters. We're like, okay, there's a username and a password field. And then you might want to query the characters in that password field. So you say, okay, in the first ACK record, whoops, let me go back. In the first ACK record here, I want the password, and then for each character. So then you would just parse through one character at a time. Should make sense. I found the easiest way to do this was to just make a Python script that could take an input curl request or something similar like that, like a post request body, and then mimic it, and then just output something that let you know how well it was working, let you imitate the threads. Yes, you can use Burp Suite for this, but it's gonna be, you're gonna be pulling some hairs out because of how tedious it's gonna be to piece it back together, especially if you don't have Burp Suite Professional and you don't have an easy way to look through it. So I'll go ahead and show you an example of this in the CTF challenge called E.Tree from Cyber Apocalypse 2021, and then we'll come back here and talk about LDAP injection. All right, it's time to go through the first challenge, which is for XPath injection. This is a challenge from Cyber Apocalypse 2021 called E.Tree. I've got Burp Suite pulled up with my proxy host listening. Let's just try and put some input in here. This military staff member does not exist. If we go and look at that burp request here, we can see it's this API search endpoint. We can see there's a failure. This person doesn't exist. Of course, going into this from the context we're going into it, we kind of already know that this is going to be XPath injection. So let's just try and put in some kind of payload, like, or what would we do it? 1 equals 1. I think we'd want to do it like that, so the syntax of these single quotes lines up just right. Doesn't exist. Maybe I'm doing something wrong here. Maybe no space there. Yeah, there we go. So as you can see, right, we know that this military staff member Gabe does not exist or shouldn't exist, but in this case we're changing this query so it's resolving to true. And I don't have it pulled up here, but because you can download the code for this challenge, we actually already know where we are in the schema and specifically what this is. So we know that there's like, if I can show you here, we know that we're in like we know that there's like there's a military object, there's a district object, and then inside of that there's the staff object, and then that's where it's actually querying for the name, the rank, the age, etc. And then what we know where we're looking for the flag, it's only in a handful of these. There should be some self-destruct code or something like that. So that's what we're going to be looking for as we kind of parse through these different things. I think we can actually start just checking for this first character. Let's try it like this. So I think what we want to do is, I have my notes pulled up. I'm kind of cheating because I don't want to waste any more of your time than I already have. So I've kind of prepared some of this ahead of time, but we're going to look for, right, or, and we want to look for the sub string. Specifically, we want to look inside the military root element, the district child the staff child, and then the self-destruct code. We want to look for this self-destruct code. What would you call it? Attribute. Specifically, we want to know the characters that are here. Maybe I can make this a little bit. Oh, is that not going to work? Yeah, this VM's new. It doesn't really, the mouse doesn't really work the way that I want it to, so this is fine. Let me actually make this a slight bit larger. Let's do like 18, and then we'll also do that for the message editor. You can kind of see that the mouse is offset a little bit, but it's okay. So let's say we're looking for that self-destruct code at 1.1, and we're going to say that that should be equal to the H character, right? Because we know that most hack the box flags start with HTB. Or actually, let's just use this for now. And whoops, and we want it to resolve the true anyway. And then we'll see if this works. Military staff member does not exist. Let's see if we swap this out with H, if it does. Amazing. So now we know that the first character in the first position, or wait, no, this is substring. So I think that just means that, no, wait, that's not how substring works. No, it's, okay, so we know this is the first character. If we want to look at the second character, we're going to swap that out with 2, swap this out with T. Boom. We know that the second character is T. Again, we can keep moving. 3, B. Whoa, who would have thought, right? We can even keep going farther, right? We know this is probably going to be an open curly brace. We know this is the 4th position. Whoa, that still works. Okay, so you guys get the idea. What I'm going to do is copy, let me just copy all this here. And I made a script that should work fine for this. Let me show you. It should be, it's this one. So what we can do is we can just pass in a request.txt file and specify what we want to filter with. And then we can just get this to work for us. So first things first, I'm going to say nano request1.txt, paste this in here, and then I'm just going to replace what we're filtering for. So this is the character, and then this is the number. I think, let me just double check here in my notes if that's actually, oh damn, I don't actually remember if this is the correct syntax. So I hope that we're lucky and I actually remembered how my script from yesterday worked. If not, we're just not going to be very lucky. And then I can just run it, which I think should just be Python 3 XPath injection request 1. And then we want to put in the success case that it should be looking for, which is this military staff member exists. There we go. And then we're filtering by text. I think that should be all we need. Okay, so what you will find about this for this challenge is that it's actually filtered into 2 different parts here. I'm fine with part of the flag being exposed here because this is a what's the word? It's a 2-parter. For the second half of this, we kind of have to work not backwards per se, but we can only get this first half of the flag here. So what we need to do is construct an additional query to get the second half, which will look something like this. So we're still going to be getting the substring, but we just need to call it from a different staff member. So I think this is probably still 1, right? Or no, is this 0 maybe? Well, which staff member is this from? Maybe this is from staff member 3? Yeah, so the context of our base query is querying staff member, or the staff object 3, I guess. We swap this over to 2, you can see that doesn't seem to work. I don't remember how long this flag is, but let me do like maybe the 8th character. And then we can just try and look for this ending one. Maybe it's 9. Maybe it's 10. Maybe it's 11. Maybe I'm just wrong about this. Maybe it's the 12th character. Maybe I am tweaking out about this. Let me think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Maybe I just didn't count high enough. 15? Okay. So now that we know this is somewhat correct, I can do the same thing with my script that I made, which is just request to. And then again, I'm just going to replace this character, and then this should be the number. And then I'm just going to do request to, because it should be the same success condition. And now you can see it starts processing the second half, but it's the exact same methodology. The only difference for that one being is that we're calling a different iteration of this same, what do you call it? We're calling a different member, not different member. Why am I blanking on this? We're calling a different staff node. It's the same, right? It's in military, it's in district, but it's just not number 3 that we were querying to start with. It's maybe the second one in the list, the second staff child node that we're querying. So that's really as, tedious as it gets. This is a little example. I'm sure it can be more tedious if you're, if you can't figure out the names of any of these and you have to call it all by number. But either way, the prevention obviously would be make sure that we can't, do this and inject into, your actual query that's running. So we'll go ahead and get back to, I think, prevention, and then we'll talk about LDAP injection. All right, so really quick before we move on to LDAP injection, the prevention is very similar to SQL injection. Make sure that you're using, prepared statements. I mean, really, that's the biggest thing. And make sure that you're sanitizing user inputs. You'll see a running theme here, and it's that you need to be sanitizing user inputs so that these queries, user inputs can't affect these queries that are being run. Now to move on, we're going to talk about LDAP injection. So this is the lightweight directory access protocol, and it's used to access directory servers, DS, like you would see used in Active Directory. Web applications can use these, of course, to query information about users, information about emails, printers, you name it. There's a lot of other terminology in here that I just straight up don't feel like including because, again, this is going to be like a case-by-case thing. You'll look this up when you need to know it. The main thing I'm going to talk about is attributes, which are just key value pairs. And then also the fact that LDAP has actions, the main one being bind that we'll talk about in the prevention steps, and search. Those are like the two main things that you'll see. So queries in LDAP are called search filters, and they look like this typically. So you search for some attribute that equals some, some attribute equals some value, some attribute equals some value. And that's basically most of the syntax we got to understand. Here's a few more examples, right? Keep in mind, attribute names are unique. There's some common ones. You can brute force them if all else is failing, which we'll look at in an example. But in this case, right, if this is our query for logging in, UID is Gabe and the password is this, the actual attribute name being used will depend on what's actually being used in the Active Directory environment. So you might have a login page that submits the username and password fields, and then it might pass in your inputs like this. You could try and modify this to just authenticate you for this one user and say the password is wildcard, which is just resolves to everything. Or if you want to look for something that has an admin username or admin substring in their username, this would work. If you can't use wildcards for some reason, you can use some additional OR clauses with this pipe character, and that should give you some good luck. If this doesn't work out, then there's some other stuff you might be able to try. You can encode it different ways, but if this isn't working, then it seems like they're properly escaping your queries, and there's not a whole lot, to my understanding, that you can do from there. Moving on to data exfiltration with LDAP injection, right? First, you need to get your attribute name. So this is what that looks like. Here's a list of common attribute names. And then we're just using the Burp Suite intruder to look through them. I'm saying, okay, my username is Gabe, and give me some attribute which is equal to, just an attribute that does exist. and the password is invalid, whatever. So it doesn't matter. Do I not have the result table for this? Either way, whatever. What this, I think in this example, I don't get back any different results, but the response is different depending on whether or not this attribute actually exists. So in an instance where you can't actually get an attribute, you might want to brute force it. So in this case, I don't actually know what this attribute might be called. So you could brute force the name of an attribute and then brute force the value of it. This is actually a little bit easier than XPath brute forcing because you don't need to specify each position. You just need to do it one at a time this way with this, if you can use the wildcard character. So again, right, you can just go through every single position and figure it out and then make a script that does all this for you. And it's not that complicated, assuming that it's just a case like this that's relatively straightforward and simple. That being said, we can look at an example in a Hack the Box machine that came out, I don't think too long ago, called Analysis. So in this case, right, there's a this internal endpoint called users where you can list the users based on their name. And if you have something like this, B star, it'll get everything where their username has a B in it, or I think in this case, it's actually their first name starts with B. I can't actually remember what field this name attribute correlated with, but either way, we can assume that, you know, we can inject some stuff like this and try and get the names for their attributes. And I think in this example, we find a couple attributes. One of them is SN or CN, and then one of them isn't actually on here, but it's another common attribute you'll see in Active Directory called the description. So in this specific machine, there's a description field, or there's a user that you can find while you're doing this process called technician. And then you find out, oh, okay, well, the description field in Active Directory, sometimes system admins will put passwords in there. So you can brute force the text content of the description field first for every user. And then you'll find that the technician user is the only one who has anything in there. You can brute force this, and then you'll get this, resulting password. You might notice that it's appending the star character if your password you're brute forcing contains the wildcard character you're using. That could cause some confusion, so just make sure you're keeping that stuff in mind. Prevention for this is pretty similar to the last one, obviously proper sanitization, but also make sure that you're escaping these parentheses, the star character, and the backslashes, and null byte characters, just so that the user's ability to inject into these queries aren't being done. The LDAP escape function in PHP will do this for you automatically, so there's not that much to be worried about. Proper sanitization does mitigate this risk almost completely, but you should still follow best practices. That means ensuring that the account that's running these queries with bind privileges has the lowest amount of privileges they need to perform these queries. Also might be a good idea to use the bind operation with the credentials of the user who's already logged in, so that the authentication, or moreover the authorization, is being delegated to some domain server, domain controller. And then you'd also want to disable the anonymous bind configuration so that this LDAP query can't be done by someone who's not authenticated in the first place. Moving on, we're going to talk about PDF generation vulnerabilities. Specifically, like lots of web applications let you provide some kind of, or they'll provide some kind of PDF generation tool for like an invoice or a report. Think about like exporting an order you have on Amazon, right? These web applications usually need some way to customize the layout, whatever. And so these libraries that they use, in this case, WK-HTML to PDF is in the command line there. These are these libraries that they're using to create these documents for you to print them, or for whatever you might be using. So in this case, right, I'm just passing in a URL and having an output, and then it creates this document. For whatever reason, you can analyze these with Exif tool after the fact if you want to know what kind, and maybe look for vulnerabilities related to the, look for vulnerabilities related to that specific tool or library that's being used. But of course, right, this is turning HTML into a PDF. So what we're going to be looking for is HTML that can be turned into JavaScript that can then be executed. Now, the logic in the HTML page will typically be executed in the context of the server running the PDF generation tool. So What that means is think about it passing through this, it's not OS command injection. It's probably not actually going to be in this context, right, where it's just some terminal command, but it's going to be run in the context of the web server that's actually running this PDF generation tool. So think about it like server-side cross-site scripting or server-side JavaScript execution, whatever makes the most sense to you. The example that we were given in the module has some input text, and we can use to print some resulting HTML. So you might be able to pass in some JavaScript like this. This should reveal the path where your resulting PDF file is being stored. And then you can also try and get it to send some HTTP requests. So you could have an image or an iframe or maybe a link loaded in the PDF that points to your server. And then upon the PDF being generated, it would send some request to your, malicious attacker guy server. You also might be able to load, do some server-side request forgery of some local infrastructure, something running on another port inside of an iframe. So here's an example where the actual text included is this test input, but I also put in this iframe that queries localhost 8080, and then you can see that it actually has some web server running there that's rendered inside the iframe when this PDF is generated. So if you in this example that I'm walking through, let's say that you might want to leverage this to read some files. You could maybe do this, right? Use open to get some certain files from the path. If this example on the left here causes issues with maybe the text breaks off into the side or doesn't fit on the PDF or something like that, you could use this script on the right to kind of make sure it returns each line and it's base 64 encoded, so it'll be a little bit easier to read, or maybe not read, but it'll be easier to process in that way. If for whatever reason you can't actually get JavaScript execution, you could still try local file inclusion. So again, trying to load some kind of local files in an iframe or an objects or portal, any of these other kinds of things. And then also keep in mind that there's different PDF libraries that support different features. So some might support annotations, some might support their own weird attachment scheme. There's also instances where if some of these tricks don't work, you might be able to add PHP to add some code to a web server that you control, and then maybe try and redirect, use like an iframe in the PDF generation to like redirect to your site and then execute JavaScript from there. It really depends. So what we're going to do to demonstrate this is just go through a little machine called Stalker on Hack the Box, easy machine that came out, I want to say at least like a year or so ago, maybe longer. But we're going to go through this and just talk about it while we go through it. And then we'll come back here and talk about prevention for PDF generation stuff. Right, we're here at the relevant step in the easy machine called Stalker, where we get to practice some PDF generation stuff. Something I can't really recommend enough for this is an extension called PDF Render that's community made. I don't think it's actually a listed extension, but this is going to make your life so much easier for looking for PDF injection, so we don't need to download and view every PDF. Again, it's just going to make your life easier. So we can kind of see what this website is doing. Geez, probably the most expensive cup on the planet, $32, unless you have to buy a ton of them, I guess. But what we can do here is we can add stuff to our basket, we can view our cart, and we can do submit purchase. And you can see here it comes up with an order ID, and even so, we can view this order ID, and it queries this API PO, and then you can see this rendered, invoice, or this, purchase record. If we go back into our repeater, we can actually see, look at that, we can control the ID, the title, and if we go back and look, right, we can actually see part of these things are included, right? The item, toilet paper, the price, the quantity, these are being rendered in the front end. So this should be not screaming at you quite yet, but you should be kind of getting the wheels turning. It's like, maybe we can do some PDF injection stuff here. So I'm not sure. I think you can do title or description or whatever. But what we'll start with first is, let me grab this request again, just so we can pull these up. And this is the, oh wait, not modified. Curious, that's weird. Whatever, we'll see what happens. So let's try this one maybe. Yeah, that looks better, I think. This is why I like this extension. There's other PDF rendering extensions, but this one will actually get this data in here. So what we can do is let's just start seeing what kind of information we can pass through here. I think the first thing that we'll try is maybe, I don't know, we could try like, let's try like an iframe. So we'll see if maybe in iframe source, yeah, let's just try like LFI through here. So we'll try and read Etsy password. I don't see why this would cause any issues. And then we just need to close out the iframe. And I feel like there shouldn't be any issues with that. It looks like we don't get any syntax errors. Let's take a look at the rendered PDF here. And it looks like that works, but we can't quite read everything. Let's add some additional information here. I think we're going to want to have our width. I think we can just say like 800, 500. Or actually, you know what? That's probably fine. Let's send that. Okay, good. That syntax isn't broken. There we go. That's much easier to read. And I think even with this, we can zoom in a little bit and look around. See, I really like this extension for that purpose. I wonder, can I minimize this? I don't know what half of these buttons do, I'll be honest with you. But it's better than the existing ones, I'll give it that much, because it actually renders this stuff in here properly. We can't quite see everything, but we can see most of this stuff, right? So that's like LFI. I don't think we can actually get any execution here. And this is Community Edition. I don't really have a server stuck up at the moment. But I suppose it wouldn't hurt to try to maybe see if we can do some server-side request forgery. So let me try. I think what we would want to do is just, let's go back here and let's just do like, right, let's open that up. Our internal IP for this machine is 10.10.14.14. So we'll go back here and let's copy this. And let's still do it inside of an iframe, but let's just, instead of this, we'll set this equal to http://10.10.14.14. And let's try and query SSRF. Send this. It looks like that was syntactically correct. Now let's send this over. Interesting. And we get this blank. I wonder. Oh, wait. Did it fail? Oh, no, that worked. Okay, so you can do some server-side request forgery stuff here. I wonder if that confused anybody when the box came out, because if you're curious, the intended solution isn't actually to do any server-side request forgery here. It's actually just to read a specific kind of file. So what I think, if I remember right, I'm going to have to check my notes here. Yeah, here's what it was. So what we want to do is look at var dev index.js. I forget why this was the file that we were supposed to be looking for. I think there was some other place earlier in the machine where you're supposed to get context. But you can look at this file. In the contents of this file, expose a password here for a MongoDB login. So you can see this dev user has this. I heard passphrases are pretty secure. And you can see, I think this is what factors into the next step. But it is interesting. I didn't try to see if there was server-side request forgery, and it appears that there is the ability to do that with the JavaScript execution that's here. So that's really interesting. But yeah, this is an example of what you could possibly do with this. And because you're executing this JavaScript in the context of the host, there's a lot of, potentially naughty stuff you could do with this. I don't see why you wouldn't be able to get a shell to fire, but I haven't actually checked to see if that's something we could do. So who knows? Maybe we'll see. But let's go ahead and get back and kind of start wrapping up, and then we'll send you on your way. All right, so again, if you want to prevent PDF generation, your HTML injection in PDF generation, right? This usually happens because the default config for these PDF generation libraries or tools isn't really secure out of the box. You'll want to look through the documentation of whatever library or tool you're using and recommend whatever relevant settings need to be configured. Of course, these all kind of stem from user input not being properly sanitized. You can mitigate this to an extent by disallowing HTML tags in user input fields and HTML entity encoding all of the user inputs so that they get parsed safely. At the very least, you want to make sure that JavaScript is not being executed under any circumstances, that access to files is absolutely not allowed, because why would this PDF generation thing need to access other files aside from writing this one file, right? And then make sure that this access to any external resources is limited, if not completely disallowed, right? This tool that's being used to generate a PDF does not need to run, this doesn't need to reach out to any other servers to get stuff. This doesn't need to do much. Obviously, business need might fluctuate a little bit, but that's the gist of it. So, yeah, that's basically it. I think we've got a conclusion slide here. In general, for all these injection attacks, right? Input sanitization, parameterized queries. The next video should be much, much shorter than this. I think we're going to push like 40 minutes for this one, but we'll see. Maybe we'll get lucky and it'll be shorter. But anyway, thanks for tuning in and listening to this, somewhat incoherent rambling fest that we've got going on. And yeah, I hope you learned something. If not, I'm sorry for wasting maybe 40 minutes of your time. Have a good one.